Hi everyone, we're going to learn to do vector addition and scalar multiplication. I put some vectors here. Please excuse the little arrows. Again, this is the tail here. It starts at the origin usually, and the tip is here. So when you're drawing vectors, please watch the previous one. We did very simple vectors. You usually draw a tail to tip type thing to get your resultant vector. So we're going to do this first example, and in this video we're doing scalar multiplication. So we have this 2 in front of the v. So here's my v, and so what I'm going to do is draw this v here twice as long. So I'm going to draw v, it's yay high, and we'll make it twice as long. And again, I'm not going to be perfect with the exact measurements, but just kind of make it twice as long. Now, u, if I were to draw just u, it would go this way. But since I'm drawing negative u, that means you're going in the opposite direction of u. So what we're going to do is put the arrow here. Sorry. We'll put the arrow here. And since we're going, this is your negative u, and this is your 2v. But since you're going the opposite direction, and we have to draw a tail to tip, we're going to go down. So this is scalar multiplication, 2v. And the negative u, we're going to draw a tail to tip. So we're going to move this guy over here, making negative to the tip of my 2v vector. So this is my 2v, and this is my negative u. Now, to get the resultant vector, the resulting vector, we're going to draw tail to tip. So we start with our original, which was 2v, and draw to the tip of the other one. And there's your vector. So it's 2v minus u, and it's this vector right here. Okay, we're going to do some more with different ideas here. I drew the vectors. This is an R. Why did it looks like an S? So that's an R. And we're going to draw R plus 1/2 of t. So the first thing I'm going to do is draw the first vector, which is R, which goes like this. Okay, half of t. So I'm taking this vector here and doing about half of that. So I'm going to draw this up here from the tip of my R. This was R. So I'm going to draw about half of that. And then to get the resulting vector, you draw from the tail of the R to the tip of the 1/2 t. So this was 1/2 t. I just halved my original. And the resulting vector is R plus 1/2 t. Okay, let's do one with subtraction. We have R, so I'm going to draw R. Again, I'm going to draw it like this. And again, it's supposed to be the same. Maybe I should make it a little shorter because it looks shorter there. Okay. Now, 2v would be this. So again, I'm going to move this down, I guess. So I'm going to draw R down here and try to make it the same magnitude. Now, 2v would go, 2v would go down like you draw it twice. You double the magnitude. But since it's negative, we're going to flip it and it's going to go up this way. Go in the opposite direction. Excuse me. So when I draw that, I'm going to draw it from tail to tip. So I'm going to draw this one from the tip of my R. And it's going to be twice as long as my V and in the opposite direction. Then to draw tail to tip, you take your original, which your first one, it was just R, and draw tail to tip here. And this would be R minus 2V, and this is negative 2V here. Okay? 3V, so I need this magnitude by 3. So I'm going to go all the way down, 1, 2, 3. 3 times my normal magnitude. And then 1/2 of R. Now, so I'm going to take my R, take half of it, and so draw it shorter here. So this would be 3V. This is 1/2 R. And we started with 3V, so I'm going to draw from, oops, we're going to draw for, okay, so this was 3V, and this was 1/2 R. We're supposed to, I drew this wrong. I knew something was wrong. You have to draw from tail to tip. Okay, so 1/2 of R. So basically 1/2 of R, I'm going to go down. I have to draw from tail to tip, so just draw half of that. Now, so this is 1/2 R. Now draw from tail to tip. So when you're drawing it and you see that something's not right, you probably drew the one of them wrong. So this would be 3V plus 1/2 R. Okay, now I'm going to draw U plus 2V. And I really want to make this minus, so I want to do some more minuses. So U minus 2V. So here's U. Um, 2V, and I'll draw it again over here. 2V would go down this way twice. But since it's negative, we're going to go in the opposite direction. So from my tail, I'm going to go in the opposite direction and draw up here, 2V. So it changed directions and the magnitude. And then all I do is draw from tail to tip, and that's going to be from my U, this is negative 2V, up to my tip, and this is U minus 2V. Okay, the next one I have is 1/2 T plus R. So 1/2 of T, I'm going to draw that first. So I'm just going to draw half of that, so it's a little smaller than my T here. Then I'm going to draw my R. My R goes down here. So this was my 1/2 T. This was my R. And I started with 1/2 T, so I'm going to draw from tail to tip. And this would be 1/2 T plus R. Okay, 5V. So that's going to be very long here. There's my V. I'm going to draw that first. So I'm trying to make it long. That supposedly is 5 times that. Just pretend it is. All right, 5. I just made it, the scalar multiplied it. Then I'm going to add my T. My T is here. So I'm going to, from tail to tip, draw my T. This is 5V. This is my T. And I start with this and get my resultant vector, which is 5V plus T. Okay, I've decided to do one more. And this one's going to be R plus 1/2 T. And this is going to be, so I'm going to draw R, which is here. Try to make it about the same. And 1/2 of T. So I'm just going to draw this is R, and 1/2 T would be about here. 1/2 of t. Draw the resulting vector. And this would be r plus 1/2 t. And the last one, I have r plus 2v. So draw r, which is here. Pretend these are the same. I'm going to erase some of this right here to make it more the same. Okay? And then we're going to 2v. So that's going to go down. Maybe I should have put this up a bit. So I'm going to put r here. There's r. And I'm going to do twice that length. And go pretty much straight downish. Twice that length. And then just draw delta tip. And this would be r plus 2v. And this is 2v. And that's basically it. Now let's have a little quick discussion. Is vector addition commutative? Yes. Because the resulting vectors would be the same. Resulting vector is the same. And what do you think about vector subtraction? You're right if you said no. Because when you subtract the opposite vectors, you are changing the direction of the resultant vectors. So the resulting vectors won't be the same because you're changing the direction. Okay, the next video is going to be about resolving vectors into x and y components.